now we're going to do some practice problems with periodic trends. One of those trends was the atomic radii. So there was a trend for atomic radii if we went across a row or down a column. So down a column, the radii got larger and larger every period or shell that you went down. As we went across a row, it actually contracted the radius because of the increase in protons, but the same shell of electrons. So greater positive charge in the nucleus, same shell, so pulled in. So let's look at what the elements are that we're going to get the atomic radii trend of. This says increasing, so it's a good idea, if it says increasing, to actually write out smaller to larger, so you're thinking about that as you put the elements in. So the largest one, if they're all in the same row together, would be the one to the farthest left, because the trend is it gets smaller as we go across. So the largest one is lithium, and you can start on either side, whichever one. The smallest one would be the one furthest to the right, which would be oxygen, and then carbon in the middle. And then after you do that, come back and say, okay, the smallest is all the way over here to the right, so it's oxygen, then carbon, then lithium. Going down, same idea, just write smaller to larger. So as you go down, it gets larger. The largest one is the iodine. The smallest one of those three is fluorine at the top, and then bromine's in the middle. And then you just look, the top is going to be the smallest, so smallest, next largest, largest. This one's a little harder. This series, if they're going across or down, just remember whatever the trend is. For this, I threw in an ion in there. So anytime there's a cation, and this was in one of the earlier sections in chapter 6, that we didn't really cover the atomic size of ions, but a cation relative to its neutral ion is going to be smaller radii. So this is smaller, and we'll just do these because cation, because it has this. So it became a cation because it lost an electron, which means it went down an entire shell in the outer shell, the valence shell. So this sodium ion is smaller than the sodium atom. And then we have to see for these two, which one's bigger. So these two are in the same column together. The potassium is lower, so it's bigger than the sodium. So the potassium's larger than the sodium. So sodium ion smaller than sodium is smaller than the potassium. So the smallest would be the sodium ion, and then the sodium atom, and then the potassium. And then if you did an example where it was, let's put it down here, an anion, the anions are larger than their neutral atom. So larger because it's an anion. Okay, we'll go over the